How are you, my friends? This is lecture number 18 of the Calculus 1 lectures, Simple Curve Sketching. Later, in lecture number 20, we will see more curve sketching, more difficult questions to graph. The objectives here in this lecture will be finding the critical points of the function where f prime is equal to 0. We look at the increasing and decreasing behavior. We will look at the behavior at infinity, which we call it far right and far left, what will happen to the graph. Also, we will find the x-intercept and any y-intercept of the function. Now, this is the polynomial function. There are many terms there. The powers are positive integers. When we say far right, x will go to plus infinity on the far right. Far left, when x goes to minus infinity. The critical points, we have seen points on the graph where the tangent line is horizontal. So f prime will be 0. Increasing and decreasing, we have discussed in the previous lecture. Now, there are 4 cases for the behavior at infinity of the polynomial functions. This is in lecture 35 of the complete algebra course. If you want to go back and check, n is the degree and a sub n here is the leading coefficient, which we call it LC. So there are 4 cases. Case 1, where we have positive in the leading coefficient and n is even, like degree 2, 4, 6, 8. So it will be up to the right, up to the left, and this is the limit. Also, in case 2, we have negative leading coefficient. It will be down to the right, down to the left. Case number 3, where we have odd degree here, n is odd, like 3, 5, 7, etc. And the leading coefficient positive, so it looks like the x cubed. And this one, n is odd, and the leading coefficient is negative. This is case number 4. Helpful ideas with graphing. You know that in many lectures, you have to find the x-intercept, let y equal 0, solve for x. Find y-intercept, let x equal 0, solve for y. Here, let's say, I will give you some nice idea here. The real solution of an equation like this. Suppose you have an equation, x cubed minus 27x is equal to 0. That's an equation, cubic. So there are 3 solutions there. The real solutions and the x-intercepts of the graph of a function, that's a function. They're very similar. Look, this is the function, x cubed minus 27x. If we make it an equation, that means we are finding the real solution or the x-intercept of this function. So the zeros or the roots or the solution of this equation are the x-intercept of this function. They are the same. Let's start with example number 1. Sketch the graph, or the same function here, f of x is equal x cubed minus 27x. You can try it if you like. Let's start with the end behavior. This is case number 3. Why? Case number 3, n is odd. So the highest degree here, power is 3. Okay, leading coefficient is positive. And the limit on the right, on the left, it goes 1 time plus infinity on the right. On the left, it goes minus infinity. Let's find the derivative. 3x squared minus 27. Take 3 as a common factor. So x squared minus 9, factor it. Difference between 2 squares, x plus 3, x minus 3. That's the derivative. Now put the derivative is equal to 0. We find the critical values. X will be 3, and x will be minus 3. X-intercept, let y is equal to 0. So take x as a common factor. X times x squared minus 27 is equal to 0. Then x will be 0, or x will be plus or minus square root of 27, which is plus or minus 3 square root of 3. So there are 3 x-intercept. We have f of x is equal x cubed minus 27x. We already found the critical values, 3 and minus 3. X-intercept also 3 values. Let's do a table of signs to study f prime, to understand more about the function itself. So we put x minus 3, x plus 3, just a normal table of signs. And we see the minuses here because all these numbers between minus infinity and minus 3 will make each factor negative. When you multiply, you get positive. So f prime is positive means f of x is increasing. F prime is negative means the function f is decreasing. So here we have a local maximum at minus 3. See the minus 3 here, we replace it in the function. Minus 3 all cubed, minus 27 times minus 3 will be 54. That's the value of the local maximum. Also at 3, we have a local minimum here, 3 and minus 54. And we have 3 values for the x-intercept, 0, 3, square root of 3. This is an ugly number. Also, we have here minus 3, square root of 3. The function decreases here, decreases between minus 3 and 3, increases. You can get it from here, minus infinity to minus 3, union 3 to infinity. Let's see another question, example number 2. F of x is equal minus 2x cubed minus 3x squared plus 12x plus 18. Let's graph this polynomial function of degree 3. First, we look at the end behavior. This is case number 4 because we have the degree here, n is odd, 3, and we have the leading coefficient minus 2, which is negative. So it looks like the minus x cubed, the shape on the far right, far left. Now f prime will be minus 6x squared minus 6x plus 12. Take 6 as a common factor. We have a minus inside here, minus x squared minus x plus 2. When you factor it, be careful here, you get x plus 2 minus x plus 1. You cannot write x minus 1. You have to write minus x plus 1. Now the critical values where f prime is equal to 0, so x will be minus 2 or x will be 1. X-intercept, put y is equal to 0, and we see here we have 4 terms, so we can use factoring by grouping, if you remember that from the algebra course, lecture number 12. Many questions are there, factoring by grouping. So you take the first 2 terms, the last 2 terms, and then there is a 2x plus 3 common factor. Then we have 6 minus x squared. We can find 3 values here for the x. X will be minus 3 over 2. And if you take this is equal to 0, you get x equals plus or minus square root of 6, also an ugly number. Let's do a table of sign here to graph this cubic function. See, this is the shape here. Will be here up to the left and down to the right. This is similar to the minus x cubed, if you remember that. Similar in the end behavior. So these are the x-intercept, these are the critical values, minus 2 and 1. So we can put here on the table of signs, we can put minus x plus 1, because this is different from x minus 1. You can put x plus 2. Take a number there as a test point. Then we see that f prime will be negative here, positive in the middle, negative there. So this is decreasing, increasing for the function f, and then decreasing. At minus 2, this is a critical value. Replace it in the function. See, put here all minus 2. You will get minus 2 here. So minus 2 is a local minimum. If you take 1 and replace it in the function, you will get 25. So that's a local maximum. There is no absolute here, because this will go to plus infinity, this will go to minus infinity. Example number 3, x to the power 4 minus 8x squared minus 9. This is an even degree. So n is even here. You see the highest power is 4. The leading coefficient is positive. So this is case number 1. It will be up to the right, up to the left. Let's find the derivative. 4x cubed minus 16x, and now the derivative of minus 9 is 0. So here we take a common factor 4x. Inside we will have x squared minus 4. That will be x plus 2, x minus 2. So the critical values when f prime is equal to 0, there are 3 critical values. X equals 0, X equals -2, X equals 2. So we will have very big, huge table of signs. X-intercept, let y is equal to 0. Now look here, put y is equal to 0. You can factor that. See, this is a trinomial. X squared plus 1, X squared minus 9. If you multiply these, you will get the function itself. Now, if you factor more, this is the difference between two squares. So these are real numbers, 3 minus 3. We can consider them as x-intercept. The other one here, x squared plus 1, if you factor more, you'll get complex zeros, plus or minus I, if you remember that. So these are not x-intercept. These are zeros of the function, but they are not real zeros. They are complex zeros. So they are not considered as x-intercept. Now we have the function here, and we have the derivative, and we have the critical values. So we can make a big, as I told you, huge table of signs, -2, 0, and 2. I put here all the factors. There is no need for the 4 because it's positive 4. If it is like a negative x or negative 4x, we can include it here. It will change the sign, but we have only x variable, x plus 2, x minus 2. Just a normal table of signs. Take a number here between minus infinity and -2, replace it in the x, you will get minus, minus, minus. Between -2 and 0, take a number here, let's say -1. It will be minus, plus, minus. Between 0 and 2, you can take 1. And between 2 and infinity, you can take any number you like, 7 or 15 or 50 or 100, any number there. So remember, this is f prime negative, f prime positive, f prime negative, f prime positive. That means the function f is decreasing and then increasing. So there is a minimum here. Increasing, then decreasing, there is a max at 0. And then decreasing, increasing, there is a min at 2. So we can put all these together on the next slide to see the nice graph of this function, x to the power 4 minus 8x squared minus 9. We have the critical values, 0, -2, and 2. See, we have here local max, we have local min, we have local min, local maximum at 0. Put 0 in the function, you get -9. So the maximum itself here is 9. It's local. And local minimum here is -2. At -2, put -2 in the function here, you'll get -25. So -2 is 25. And f of 2 also is -25 if you replace 2 by in the function itself. Now, always please check the playlist Calculus 1 solved questions for more and more questions to understand about sketching polynomials and other functions. This is the end of lecture 18. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.